now we will turn our attention to series. A series is the sum of the terms of a sequence. Okay, that's all it is. So basically, if you have a sequence, you add some or all of the terms up. Okay, that's what a series is. How do you indicate a series? Well, a series is written using summation notation. The Greek capital letter sigma is used to indicate a sum. Okay, so if you see this symbol right here, which is pronounced sigma, that just means add everything up. Okay, so let me write that down. Okay, so if you see this, this means add everything up. Okay, that symbol turns a sequence into a series, basically. Okay, so as far as a series goes, you can have either a finite series or an infinite series. So let me start by talking about finite series. And in doing so, I'm going to pop down here and talk about the pieces of summation notation. Okay. So if you are dealing with a finite series, what that means is, I know this kind of looks very mathy and maybe a little intimidating, but basically what a finite series is you're adding the first in terms of the sequence. Okay? So basically, if I look at this statement here, there's three parts. There's the left piece, then what's in between the two equal symbols, and then you've got the summation piece. Okay, let's start in the middle here. So basically, we know A1 is the first term of the sequence, A2 is the second term, A3 is the third term. Dot 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 means we go all the way up to AN, which is the nth term. Okay, so you can see right here, that's exactly what I just stated. You would be adding the first in terms of the sequence, A1 all the way through AN. Okay. Alternative ways of writing that, so you don't have to keep writing term after term after term. If you see SN, that's another way to write it, that you're adding the first in terms of the sequence. Think of S for sum. Okay, so then the little subscript in would be meaning, that you're adding the first in terms. Okay, the more common way that you're going to see it as far as shorthand notation is going to be through the summation notation, which is right here. So I'm going to come down here, okay, and basically dissect this for you, go through the different parts of this notation so you understand what it all means. Okay, again, the key is seeing this sigma notation. As soon as you see that, that means add all the terms up. Okay, so obviously there's more to the summation notation other than the sigma, so let's talk about it. Okay, with this sigma, okay, there's going to be a number below it and a number above it. Okay, let's start with the number below it. So here it starts at 1. It doesn't always start at 1. Okay, but generally, that's a good starting place to start with the first counting number. But again, it's not a requirement to start with n equals 1. It can start somewhere else. Okay, again, this is going to be the term that you're starting with. Okay, so if I say I equals 1, I'm starting with the first term. If I say I equals 5, I'm starting with the fifth term. Okay, so basically the lower number is going to be your starting point. Okay, the top number is going to be your stopping point. Okay, that's what it says right there. Okay, so usually it will have a number there instead of in. Okay, so if I had 9 here, okay, that means I would stop at the ninth term. Okay, so I would start at the first term, I would add all the way from the first term through the ninth term. Okay, I'd be adding A1 through A9. Okay, so that's what those numbers mean. Okay, you've got the starting point at the bottom, the stopping point at the top, and then let me talk about this variable I. Okay, I is the index of summation. Okay, it's basically your counter. Okay, I'll put I keeps track of which term you're on. Okay. Usually I, J, or K is used as the index of summation. Okay, so it's possible that you'll see a J or a K there as well. It's just keeping track of which term you're on. You're going to start with I equals 1, then you're going to keep bumping it up one by one until you get to I equals the stopping point. Okay, notice that whatever this variable is, whether it's I, J, or K, it is going to be involved over here with this expression. Okay, what this AI is, that's your formula for the ith term of the sequence. Okay, so basically how you come up with the terms of the sequence, that's going to be this piece right here, the AI. Okay, so that's basically all the pieces of the summation notation. You recognize it by the sigma. The bottom number is going to tell you what term to start with. The top number is going to tell you what term to stop with. And then what you're adding up, this piece right here, that's how the terms of the sequence that's how the terms are generated. Okay, that's the formula. Okay. All right, so like I said, if you're dealing with a finite series, you're adding the first n terms of the sequence, okay? And the answer is just going to be a number, okay? If I add up the first n terms, the sum is blah, blah, blah. It's just going to be a number, okay? It is possible, because we know a sequence can go on forever, it is possible to add all the terms of a sequence, okay? In that case, you're going to be dealing with an infinite series, okay? You're adding an infinitely many number of terms, okay? So here you're adding infinitely many terms because a sequence can just keep going, okay? So if you look in the middle here, you would start with A1, the first term, you add A2, A3, and so on. Eventually you get to the nth term, but you keep adding. So that's why you see the plus dot dot dot, okay? So the way this is going to be notated in shorthand notation, instead of Sn, you're going to see S infinity. That means I add up all the terms, okay, not just the first n terms. As far as the summation notation is going to go, the difference here, the only thing that changes, instead of having a number on top, you would have infinity. Okay, that means I'm adding everything up, infinitely many terms of the sequence. Okay, it seems kind of weird, like, okay, how can I add infinitely many things? It is possible to add all infinitely many terms of a sequence and actually come up with a number. Okay, that sounds weird, but it is possible. You will see that. Okay, sometimes it isn't possible to add all the terms of a sequence, add infinitely many terms, and come up with a number. Okay, so we will talk about that. Okay, but just for right now, you need to keep, you need to understand the difference between a finite series and an infinite series. If it's finite, I'm adding the first n many terms of the sequence. If I have an infinite series, I'm adding infinitely many terms. Okay. All right, so I think this last little piece here talks about the index of summation, which is the I letter, which could also be J or K, okay? But again, this is key here, understanding the pieces of the summation notation, okay? So like I said, you'll get plenty of practice with it, okay? Before we do an example, I want to jump to the top of page 4, okay? Some words you will hear associated with series is convergent versus divergent. Okay, this is going to be a huge part of calculus 2, so you're going to start learning about it now. If you have a series, it is either going to be convergent or divergent. Okay, so convergent, what that means, a series is convergent if it is equal to some finite value L. The series is said to converge to L. Okay, so to make this easier, what convergent means is you can add the series up. Okay, you can add the series up to some number L. Okay, you're able to add it up. Okay, I add the series up and I'm going to get a number. Okay. The series converges to 24. I add up all the numbers and I get 24. Okay. Like I said, especially in the case of an infinite series, you may not be able to add everything up and come up with a number. Okay. So if you can't add it all up and get one number, then the series is considered to be divergent. Okay, so if you can add everything up and come up with a number, a sum of all the terms, that means the series is convergent. It converges to that number. Okay, if you keep trying to add up all the terms and you just can't come up with a number, and there's different examples of that happening, your series won't converge, so it's considered to be divergent. Okay, two very important statements related to this. Okay, every finite series converges. Okay, because you're adding up a countable number of terms, so you're going to be able to come up with the number that the series adds up to or converges to. Okay, every finite series converges. Okay, on the flip side, if you are dealing with an infinite series, it may or may not converge. It just depends on the series or the sequence itself. So some infinite series diverge, whereas others converge. Okay? All right, so now that we're familiar with the terminology associated with a series, let's do example 3.